Hello, this is Mrs. Myers, and today we're going to learn lesson 1.5. This actually corresponds with the textbook that we use, section 2.6, give or take. So basically we're going to be talking more about proofs, and specifically about proving angles that are congruent. What you're going to see in this lesson is that there are really two types of proofs we can write. There are proofs where we are proving a specific given and prove statement that they have given us. Sometimes though, which that's what we've been doing, but sometimes you'll see in this lesson, we actually are going to prove a theorem. And there's a little bit of a different set of rules that goes with proving a theorem. So you're going to see that difference. Okay, so a theorem, by definition, is a statement that can be demonstrated to be true using a formal proof. So we've talked about postulates and theorems. Postulates we accept as being true without having to prove them, but theorems we actually have to write out a formal proof. So that's where you're going to see the difference here. Postulates, are ideas that can't be proven. Theorems are ideas that once somebody writes a formal proof, that's what makes it become a theorem. Okay? Many theorems are stated as conditionals, if-then statements, which we've learned about. The first theorem that we're going to talk about today is one that you're familiar with, the vertical angles theorem. Basically says if two angles are vertical angles are congruent is one way of stating this theorem, but we've also stated it as a conditional. If two angles are vertical angles, then they are congruent. So that's the same theorem written as a conditional, or just vertical angles are congruent is, stated not as a conditional, but it's the same theorem. Okay, so if we do write it as a conditional, we can identify the hypothesis and conclusion. So the hypothesis is two angles are vertical angles, right? The hypothesis is the part that comes between the if and the then. The conclusion is they are congruent. And remember, we don't include the word if or then when we're asked for the hypothesis and conclusion. Okay. The hypothesis, when we're proving this theorem, becomes the given. And the conclusion, when we're proving this theorem, becomes the proof. So this is the proof that we're going to write right now, is the proof of the vertical angles theorem. That's why it's a theorem, because we can write out a formal proof of it. So here's a rule that is going to be true when you're writing proofs of theorems. You cannot use the vertical angles theorem in the proof. So since it's the proof of the theorem, we can't use the vertical angles theorem to prove the vertical angles theorem, because that's what we're trying to prove. So you can't assume it's already true and use it to try to prove it. So that's the rule that you kind of have to remember when you're proving a theorem, is that you can't use that particular theorem as any reason in the proof. You have to use other reasons. Okay, we're going to start the same way though. Angle 2 and angle 4 are vertical angles. So like I said, that's like the hypothesis. Two angles are vertical angles. And proving they're congruent is the conclusion of our theorem. That's what we're trying to get to. So we look at this diagram and, we have to come up with a different relationship to use. We can't use the vertical angle relationship because we have to kind of assume we don't know that theorem's true yet, that they're congruent. So when we look at this intersection of two lines, we've learned that there's other relationships in here, specifically linear pairs, right? So what we're going to do is we're going to say angle 1 and angle 2 are supplementary, and angle 1 and angle 4 are supplementary. Now, we could have used different combinations, but these are the two by the linear pair postulate that we want to state. Well, if the measure of angle 1 and 2 are supplementary, we could write measure of angle 1 plus measure of angle 2 equals 180. And 1 and 4 are supplementary. Measure of angle 1 plus measure of angle 4 equals 180. Now notice I put these linear pairs in the same box. You could put them in two separate boxes, but if it's the same reason, you can actually put them in the same box. Okay, so both of these are going to be definition of, hopefully you're thinking of what this would be, definition of what? Supplementary, right? This is one of our common combinations. Well, if 1 plus 2 equals 180 and 1 plus 4 equals 180, we've learned that if two things are equal to the same value, then we can set them equal to each other by substitution. So we can say measure of angle 1 plus measure of angle 2 equals the measure of angle 1 plus the measure of angle 4. Since they're both equal to 180, they're equal to each other by substitution. Well, now what we're trying to prove is 4 is congruent to 2. So from here, we have the measure of angle 1 on both sides. We can subtract that. Measure of angle 2 equals the measure of angle 4 by subtraction. Sorry, I'm running out of room here. And so our last thing is angle 4 is congruent to angle 2 by definition of congruent. And we're not going to worry that it's in a different order. It's okay. Okay, so notice we proved that if two angles are vertical angles, it's our given, then they are congruent. And we had to prove it without using the theorem, so we used linear pair postulate in this diagram to show that we could follow steps to actually get to the point where they're congruent. Once we've proven this theorem, once we've proven that if two angles are vertical angles, then they are congruent, going forward now, you don't have to go through all of these steps every time to get to that conclusion. We've proven that it's a theorem, so now you can use the vertical angles theorem in proofs. Okay, so reflexive property we've learned before, and we learned it as a property of equality. Now we can learn it as, so now we can use it as a property of congruence also. So reflexive property of equality said measure of angle A equals measure of angle A, or A equals A, or whatever. Now it's just a congruent sign instead. So it's just a property of congruence. Remember, we used POE for property of equality. Now it's going to be POC for property of congruence. And it's the same exact thing, just using congruent signs. So transitive as well. We said A equals B and B equals C, then A equals C. Now we're going to say if A is congruent to B and B is congruent to C, then A is congruent to C. Same thing, definition of congruence. We've had this before, right? If things are congruent, then we can say they're equal. Or vice versa, we could say if they're equal, then we say they're congruent. In a proof, definition of congruence is the reason either way. All right, so now that we've proven that it's a theorem, we can use it in a proof. This becomes a lot shorter and easier. Our given is angle 1 is congruent to angle 4. Let's mark our diagram. 1 is congruent to 4. Well, now we know the vertical angles theorem is true. We have to prove that angle 2 is congruent to angle 3, 2 and 3. So using vertical angles, we can state the relationship. Angle 1 is congruent to angle 3 by the vertical angles theorem. And angle 2 is congruent to angle 4 by the vertical angles theorem. Okay, so now is when we should have our discussion about the transitive bucket. Because when you see that you have a lot of statements of congruence, where a lot of the angles or segments or whatever are being related to each other, you should think, well, let's see, maybe I could use the transitive property here. And so we like to talk about the transitive bucket. I'm going to draw a little bucket up here. And the idea of the transitive bucket is whenever you have a congruent statement or equal statement, you could put that pair of angles into the bucket. 1 and 4 go in the same bucket because they're stated congruent to each other. When you get to your next congruent statement, 1 is congruent to 3, well, 1 and 3 could go in the same bucket. Well, since 1 is already in this bucket we've started, then 3 can be added because it partners with 1. Then you get to your next congruent statement. 2 is congruent to 4. That means 2 and 4 can go in the same bucket. We look at our bucket and 4 is already in there. That means we can add 2 to this bucket because it partners with 4. So when we're done, we have this transitive bucket. And we can state any of these angles that are in this same bucket congruent to each other by the transitive property. So we're trying to prove 2 is congruent to 3. If we look in our bucket, is 2 congruent to 3? Yeah, because they're in the same bucket. So we could go straight to saying, oops, sorry, oh my goodness, straight to saying angle 2 is congruent to angle 3 using all 3 of these statements and the transitive property of congruence. Okay, so we don't have to worry about ordering them in any particular order. We just know that if they're all in the same bucket, we can use transitive property. Okay, so there's more theorems that we are going to be able to prove and use. The right angles theorem is a very popular theorem, right angles theorem. If two angles are right angles, then they are congruent. So whenever you are given or have discovered that two angles are right, you can automatically say that they're congruent using this theorem. So I guess I gave you this answer without going through this exercise here, but if you think about two angles that are right angles, then each angle is 90 degrees, right? So then if they're both 90 degrees, then they have to be congruent to each other. So that's basically the logic we're going to use here to prove the right angles theorem. Remember, right here, since this is a proof of the theorem, you can't use the theorem as any of the reasons. So here we have our given. Remember, the hypothesis becomes our given, right? If two angles are right angles. So our given is angle 1 is a right angle, and angle 2 is a right angle. So we can mark our diagram here. Angle 1 is a right angle. That's given. Angle 2 is a right angle. And that's given. Now we're going to basically make a conclusion from this. Angle 1 is a right angle. Well, what can you conclude about angle 1? Well, hopefully, if somebody tells you that there's a right angle, you know that its measure is 90 degrees. This is the definition of, can you guess, right angle, right? Remember, whenever you're going to use definition of something, it has to be a term that's been used or stated somewhere in the proof. So angle 1 is a right angle. Oh, so angle 1 is 90 degrees. That's because I know what a right angle is. Definition of right angle. So we could do the same thing here by the same reason. Well, now if measure of angle 1 equals 90 and measure of angle 2 equals 90, we can say that measure of angle 1 equals measure of angle 2. Remember, if two things are equal to the same value, then they're equal to each other just by substitution. Well, now we can make our final statement that we're trying to prove. Angle 1 is congruent to angle 2. Remember, moving a statement from equals to congruence is just definition of congruent. All right, so let's look at this theorem. If two angles are congruent and supplementary, then each angle is A. So if you think about if two angles are congruent and supplementary, that means they have to add up to 180 and they both have to be the same. Well, then what would each angle have to be? Each one would have to be 90, right? So each angle is a right angle. So that's the theorem. Again, we're going to prove this theorem. Well, proving this theorem, again, since we're proving the theorem, you can't use that theorem as a reason in the proof, but we can prove it using other methods, other knowledge that we have of the geometry that's in our diagram and in our statements. So, angle 1 is congruent to angle 2. Okay, we can mark them congruent. And they're supplementary. We're trying to prove that each one is a right angle. So this proof is a little bit longer, so don't write too big. So all we have to go on is our diagram and our givens here. So we're going to try to make some conclusions from these givens. First of all, if you're told that two angles are supplementary, you know you can write this equation. Measure of angle 1 plus measure of angle 2 equals 180, because you know what supplementary means. You know the definition of supplementary. Well, since we're dealing with equations and measures of angles, we probably want to turn this into an equals statement so that we can substitute it and stuff into our proof. So, definition of congruent here. Well, since we know that 1 plus 2 is 180 and 1 equals 2, we can actually rewrite this statement, measure of angle 1 plus the measure of angle 1 equals 180. Because 1 and 2 are the same, I could substitute measure of angle 1 in where the angle 2 was. And that's just substitution. So then from here we can say 2 times the measure of angle 1 equals 180. And that's basically just combining like terms or simplifying. Well, now we can divide both sides by 2 and get measure of angle 1 equals 90. That's just division. Divide both sides by 2. Then we can say, by substitution, measure of angle 2 equals 90. Because if 1 equals 2, then you can substitute 2 in where the 1 goes and say 1 is 90. That's just substitution. And then each of these lead to the same conclusion. If the measure of angle 1 equals 90 degrees, then angle 1 is a right angle. And if measure of angle 2 is 90 degrees, then angle 2 is a right angle. So we've proven, these are both by definition of right angle. So we've proven that if two angles are both congruent and supplementary, we follow these steps and prove that each one of them must be a right angle. Now, I know that seems like a lot of steps for something that you felt was kind of an obvious thing, perhaps. And so now that we've proven that it's a theorem, then we can use it. We don't have to go through all of those steps every time we're given two angles that are congruent and supplementary. We can just use that theorem. Okay, here's another theorem. This theorem is actually a very useful theorem, and when we look at discovering this, okay, first draw two angles that are supplements of the same angle. So if we use angle A, which is 60 degrees, right, and I ask you to draw angle B that is supplementary to angle A. So how many degrees would angle B have to be? Well, if they're supplementary, they have to add up to 180. Angle A is 60. That means angle B would have to be 120 degrees. All right, now this next one says, now draw angle C, so that it's also supplementary to A, supplementary to our 60 degrees. Well, hopefully when you go to draw angle C, you realize, well, if that has to be supplementary, it's also going to be 120 degrees. So, both of them are 120 degrees. What can we say about B and C? Well, they're equal, or congruent. So, this theorem is called the congruent supplements theorem. And it says if two angles are both supplementary or supplements of the same angle, then the two angles are congruent to each other. So in our example here, B was supplementary to A, C was supplementary to A, so two angles, both supplementary to the same angle, so then B and C had to be congruent to each other. Hopefully that makes sense to you. In this parenthesis here, this is a little, additional situation where this can be applied, and we'll see what that means a little bit later. But it basically says if I gave you angle A is 60 degrees and I gave you like angle D is also 60 degrees, and I said draw angle B so it's supplementary to A, but C so it's supplementary to D, well, since A and D are the same, well, then B and C would still have to be the same. So that's what this is saying, that if you have two angles that are supplementary to the same angle, the same exact angle, like we did the first time, angle A, or of congruent angles. So the second time, two angles A and D which were congruent to each other, this theorem still works, as if it's the same angle. Okay, so proof of the congruent supplements theorem. Again, same rule, right? We can't actually use that theorem until we've proven it, and we can't use the theorem as reasons in the proof of the theorem, but after this, you will see how the congruent supplements theorem actually makes proofs shorter and easier because you don't have to go through all of these steps every time. So, if angle A and angle B are supplementary, and angle A and angle C are supplementary, then we're trying to prove that B is congruent to C. So we have A and B supplementary, and A and C supplementary. So we have two angles, B and C, that are both supplementary to the same angle, A. So we're going to just make our conclusions. Measure of angle A plus measure of angle B must be 180, because from that given statement, that's about the only thing we can conclude here. Definition of supplementary. And then A and C are supplementary, so we can say measure of angle A plus measure of angle C equals 180. Definition of supplementary. So since both of these expressions, A plus B is 180 and A plus C is 180, if two expressions are equal to the same amount, we can set them equal to each other. So measure of angle A plus measure of angle B equals measure of angle A plus measure of angle C by substitution. So now we have the measure of angle A on both sides. We can subtract that. Measure of angle A from both sides. We get the measure of angle B equals the measure of angle C by subtraction. And then we can say that angle B is congruent to angle C by definition of congruent. Okay, so we've proven that if two angles are both supplementary to the same angle, then they are congruent to each other. Well, the same thing goes with the word complementary. If you have a 60-degree angle and you draw an angle that's complementary to it, how many degrees would it have to be? Complementary, remember, adds up to 90. So if A is 60, angle B would have to be 30. If we draw another angle, again, angle C, also complementary to it, this would have to be 30. So this is called the congruent complements theorem. And again, if two angles are complements of the same angle, the parentheses means, or of congruent angles, then the two angles are congruent. So we could fill this in. Each angle would have to be 30 degrees, and so they are congruent to each other. All right, proving the congruent complements theorem is going to work the same way. If we know that angle 2 and angle 4 are complementary, and angle 3 and angle 5 are complementary. So notice here we're proving that little parenthesis part, or of congruent angles. So we don't have two angles in this case that are both complementary to the same angle, but they make this given. 4 is congruent to 5. So 4 and 5 are the same, then we have a congruent complements theorem situation. 4 is congruent to 5. So they might as well be the same angle. Two angles that are complementary to the same value of an angle. So angle 4 congruent to angle 5 is also a given. So I'd actually like you to try to make some conclusions off of each of these without me, and then, check. Just make a statement from here. What statement could you make? Angle 2 and angle 4 are complementary. What do you think that next step would be? And angle 3 and angle 5 are complementary. What do you think that next step would be? And again, one conclusion from here. So just pause the video for a second and write those conclusions, and then turn the video back on and check your answers. Okay, so you should have made the conclusion, measure of angle 2 plus measure of angle 4 equals 90 by definition of complementary. And also for this one, measure of angle 3 plus measure of angle 5 equals 90 by definition of complementary. And from here, you could just turn the congruence into an equals statement by definition of congruent. Okay, so hopefully you got those right. Now, let's look. We have two things that are both equal to 90. So again, pause the video and make a statement from these two. Okay, hopefully you recognize now that if you have two things that are equal to the same value, then you can set them equal to each other. So measure of angle 2 plus measure of angle 4 equals measure of angle 3 plus measure of angle 5 by substitution. Okay, so now is when, this might be a little bit of a tricky part, but you have to realize that what we're trying to get to is 2 is congruent to 3. And right now we have 2 on one side, 3 on the other side. So it would be nice if we could, subtract out this and this, right? Measure of angle 4 and measure of angle 5, 4 from one side and 5 from the other side. And so you could do that right away because 4 and 5 are already established as being equal to each other. Sometimes it makes people feel better to make a substitution first. Since 4 equals 5, I could just kick out this 4 and make it a 5. So keep everything else the same from the equation above, and the only thing we changed is that 4 kicked out and was replaced with a 5. So that was just a substitution of 4 with 5. Now it's a little bit easier to accept the fact that we're subtracting the same thing from both sides. Measure of angle 2 equals the measure of angle 3 by subtraction. And then angle 2 is congruent to angle 3, which is what we're trying to prove. And since we're just going from equals to congruence, it's just definition of congruent. We probably, definitely, actually would need an arrow right here because that's the substitution we used. Remember, whenever you use substitution, there's really going to always be more than one arrow coming to a substitution box because there should be something that you're replacing with each other into another equation. So we used this equation, so that arrow comes to the substitution. But the thing that we substituted should be the other arrow that comes in. Okay, so that's the proof of the congruent complements theorem. Now, these next few pages is practicing some of these proofs. So it's going to be applying these theorems to some of the proofs that we would actually have on a test or a quiz, proofs that you would be practicing. So remember, now that we have proven these theorems, we can actually use them in proofs, right? So this first example is just to show you how the congruent supplements theorem can make a proof shorter. So I'm going to do, you can see proof number 1 and proof number 2 are actually the same exact proof, but we're going to do it 2 different ways. So measure of angle 1 plus measure of angle 3 equals 180. We've done a proof similar to this before. When we look at our diagram, here's 1, here's 3. In our diagram, we might not, we would have to look and see what relationships we know about, and you might recognize that 2 and 3 are a linear pair, so you could say angle 2 and angle 3 are supplementary by the linear pair postulate. Well, since they're supplementary, our natural next step would be to say that they add up to 180. This is what we are kind of used to doing. That usually would be our next step. And so now we have 2 things that are both equal to 180. Oops, forgot my 1 there. Measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. 2 things are both equal to the same value, then they're equal to each other by substitution. And then you could just subtract the measure of angle 3 from both sides. And we've gotten to the point where we can now say that angle 1 is congruent to angle 2 by definition of congruent. And that's kind of like the routine that we've been in. But now I'd like to show you this proof with keeping in mind that we have this new theorem now called the congruent supplements theorem. We're going to start the exact same way. Angle 2 and angle 3 are supplementary. linear pair postulate. But now you should be thinking to yourself, oh, well, the word supplementary is there. I wonder if I could use the congruent supplements theorem. So we kind of do the reverse thinking here. Since we know 1 and 3 are equal to 180, then we could say angle 1 and angle 3 are supplementary, right? By definition of supplementary. Now we have two statements of supplementary. We have 1 is supplementary to 3, and 2 is supplementary to 3. So this is the congruent supplements theorem. If 1 is supplementary to 3, and 2 is supplementary to the same angle, 3, and two angles are both supplementary to the same angle, you can automatically say they're congruent to each other. And the reason is the congruent supplements theorem. So you can see how it made that proof a little bit shorter. You don't have to go through all this logic of saying two things are equal to 180, so they're equal to each other, and all the substitution. If you recognize you have two statements of supplementary, then you can just go straight to saying they're congruent to each other by congruent supplements theorem. Okay, so keep that in mind as you do the next few proofs, and keep in mind the right angles theorem as you do the next few proofs, and the vertical angles theorem. Okay, so I'm going to stop the video now and let you practice a few of these on your own. So as part of your homework, I would like you to try to complete this proof, and I'll give you a hint. It uses the congruent supplements theorem. And this proof, and I'll give you a hint. It uses the right angles theorem. And this proof. And it says right here that it uses the vertical angles theorem. So try those three proofs as part of completing this video. And we will, I will post the answers to this packet, and you can check your answers online. Okay, great. Thank you.